And together with my colleague here, today we want to tell you a little bit of a story. And the story is about Amazon and how they went from being frustrated with AI to actually being more AI native. And we hope you can take something away from this journey. We will show some internal tools that Amazon uses and bring you onto the journey of how you can also get better output with AI. So over to you.
Thank you, Robert. Also a warm welcome from my side. My name is Jörg. As Robert said, I'm also a solutions architect, working with customers and also doing lots of specialized engagement on our agentic coding IDE Kiro. So what are we going to talk about today, right? So we'll start with some tips and techniques how we as AWS tweak our AI-assisted coding to be confident in the results of it. We will then look into how we build those techniques into AI-native IDEs, and then we will also look at how we extend these techniques from just the coding perspective to the whole software development lifecycle, and also beyond just the developer personas to people like product managers, technical product managers, and so on and so forth. We'll then look into frontier agents, so what can they do, how they can become our new AI teammates, and then Robert is going to take over again, showing you some demos on how to go AI native and what we do in AWS and how you can also use our products in order to do very same things that we do internally with internal products. So let's get started. The whole journey started back in 2024, right, where our principal engineer, James Hood, he looked into the promises of AI, right? Everybody promised the world. They said AIs, if you looked at YouTube demos, if you looked at TikTok, everybody was promising you that AI is going to save the world. We are not going to need developers anymore, and so on and so forth. So this was the marketing slogan, right? But then if you looked into the reality, you basically didn't like what you see, right? It didn't live up to the promise. And if I ask around, who of you also felt like this or is still feeling like this? Like AI might overpromise on what it can achieve. So we have a couple of hands going up. And that's also what James back in the days had the impression on, right? So what he did, he thought about how can he take this AI frustration into AI productivity, right? And he came up with some techniques and how to be confident on the output of AI. So how to move from frustrated into being productive with AI. And the key insight he had basically was we need to give the AI the structure in order to follow a really rigid process in order to come up with useful results. How do we do that, right? He invented a technique we called prompt-driven development, or PDD in short. And we now call it spec-driven development. So if you look into our AI-native IDE Kiro, we support the spec-driven development process, where you basically, what you want to achieve is you want to go from rough idea to implementation, and you want to get the implementation right. But with a vibe coding, where you don't really give much more details, much more context to the AI, you are in a hard place to do so, right? So you need to tell the AI multiple in-between steps to follow a structured approach to get from rough idea to implementation. And the steps are basically the same you follow during the regular development lifecycle as a human developer, right? You wouldn't take an epic from your product owner and just start implementing it, right? You would want to go into refinement. You would want to understand what is already in the existing code base. You would want to ask the product manager a couple of questions. Hey, how do you think this feature should work? And so on and so forth. And only once you have the answer to those questions, you would start with a technical solution design. Then you would create, I don't know, out of the epic, you would create stories. Out of the stories, you would create tasks. And then you would have a detailed list of tasks which you need to implement in order to come up with the working implementation. And that is the very same thing James did, right? And this realization that you need to embed those techniques into the tools to get the proper results kickstarted an internal Gen AI power users community within AWS. And what we did there, we shared prompts to do different things with AI, right? One of them is the prompt-driven development. So if you want to develop something that was the script, you would need to add into your Amazon Q Developer CLI. So back in the days, we had a product called Amazon Q Developer CLI, which is nowadays the Kiro CLI. So this is our agentic coding tool on the CLI. We also have an IDE. We'll talk about that later on. But what those tools, those techniques, which is like a really sophisticated hundreds of lines of prompting instructions, what that added to the tools is the confidence, right? Because once the tool started following this step-by-step approach, we were confident that the results we are going to get from the tool actually do what we ask it to do and not come up with something we never wanted it to do. And you can make use of those scripts too. We nowadays call them agent subs, so agent standard operating procedures. And we have a GitHub repository where you can, for example, also see the prompt we internally used during those prompt-driven development phases. That was already a good start, right? But we needed to manually work on those prompts. If someone updated the prompt and pushed it to Git, you need to have to do a git pull to get it available locally. So there were lots of manually steps involved in pulling the prompt, configuring your CLI, making the prompt available to the CLI, switching to the agent you would want to use. So there were still lots of manual steps involved, which led us to the development of AI native solutions like Kiro IDE. And it does exactly, for example, what I mentioned with the PDD. It ingrains this process, it embeds this process directly, natively into the tool, into the IDE. So basically, it follows the same steps I mentioned earlier on. You give it a feature description. Kiro will start asking you questions about how you would want to implement it. It will come up with user stories, user acceptance criteria, and you can go back and forth, refining and making sure that actually the user acceptance criteria, the user stories created by Kiro is what you want. Out of those user stories, you will then design a technical specification, a design markdown document Kiro will create for you, and the same process is done again. So you go back and forth with Kiro, refine, explain, course correct the AI, and once you are confident with the technical design suggested by Kiro, it will create you a task list of multiple steps it needs to follow in order to implement what you'd want to do, and then you can obviously also have Kiro doing the task. So instead of manually adding those techniques into the tools, we basically embedded and codified those techniques in the tools nowadays, which makes it really easy to get started with this prompt-driven development or spec-driven development approach. And this was really nice and helped the developers, but obviously developers also not only write code, they do other things during their SDLC, right? So also you'd want to extend the usage of AI into other parts of the software development lifecycle, and this is what we are going to talk about now. So what are you doing as part of your daily tasks? So you only spend a fraction of your time actually writing code. You need to plan, you need to research the technologies you would want to use, you need to research the features you'd want to develop, and then is only once you have a basic set of understanding of what you'd want to do, then is when you start coding. And then obviously once you finish the coding, you do pen testing, you do security testing, you do integration testing, and so on and so forth. And only once you've deployed into production is where the main part of the SDLC starts, because we would hope that our software runs in production for a long time. And this is where you enter the maintain, transform, and modernize phase. This is where you fix bugs. This is where you have to update runtime libraries, where you have to update SDKs, and so on and so forth. And this is also a big part of the software development lifecycle. The challenges you face, I said it, you only have a very fraction of your time available in actually creating the features, creating the code, right? So you do other things, you have to read documentation, and if it's only a tiny little thing of the documentation you need, you still have to read multiple pages, potentially multiple websites, in order to find that very thing you're looking for. You obviously also have to write emails, you have to go to meetings, and so on and so forth. And then once the software is running, you need to find out why a bug is happening, what is breaking the software. So you need to do issue triaging and management of those issues, creating those issues in your Jira or whatever you use for issue management, and then fix those issues, obviously. And these are all points where AI is really good, really excels in helping you in those things. And we'll now go through different phases of the SDLC and map what we did internally at Amazon to help us in those SDLC phases, and then also look at what you as an AWS customer can use in order to rebuild something similar of what we are doing internally. So we already covered Kiro, right? So with Kiro, we have our design and develop SDLC phase covered. So we can use the IDE, we can use the CLI in order to come up with ideas to refine and then implement things. But in the research and plan phase, we internally use a tool called Pippin. As I said, it's internal, it's not available to you, but it's aimed towards product managers. So it's not aimed towards a developer persona, but rather to a product management role. Technical product management is a persona who uses this tool. And what does it look like? It's not a CLI, it's not an IDE, because those are things not really known to those persona types, right? A product manager does not use a CLI on his Windows machine or whatever, but what they do use is obviously browsers, and that's why Pippin is a browser tool. So it's web-based and very accessible to personas which are not developers. What does it do? You can basically select what kind of persona you would want to be today, product manager as an example, and then you can start chatting with it and start creating documents with it. We, as Amazon, we have an internal document format which is called a press release / FAQ, which is basically a fictitious, future-looking press release of a product we develop. So we are just starting developing the product, but before we even start, we write a press release looking into the future at the day of when the product is released. So if you plan to release a product in the end of the year, then you might write a press release now announcing this product already to your customers. And this is where also many of the FAQs come out of, right? So we take this PR FAQ document to get a better understanding of what we'd actually want to build. And this is what, for example, product managers build with Pippin. Once they created this, they can also ask Pippin to already create development tasks out of it. So it's connected to our internal task management system, which is called Tasky. So once we are confident in the PR FAQ, into the requirements document we'd want to implement, we can ask Pippin, hey, please now go ahead and create the tasks, which we then are going to hand over to the developer. And if you, as a customer, want to do something similar, you can use Amazon Quick, for example. Amazon Quick is our customer-facing equivalent of Pippin, so to say. It comes as a desktop application and as a web application. And what you can do is you can use it as your company-wide AI assistant. So you can hook it up to your internal sources, you can hook it up to your wiki, you can hook it up to your Jira, you can hook it up to Slack, and so on and so forth. It can read your emails if you give it access to it. And with that, you can also do very similar things of what we do internally with Pippin. You can create custom agents there, so you can create those personas. So you describe to Quick, hey, I want to create a custom agent who's embodying a product manager, for example. You explain what a product manager is doing on a day-to-day basis, and then Pippin Quick can also help you to do the very same things we do with Pippin internally, yes. You can organize your information around spaces. So if you have teams working on different products, you can share spaces with them, and with that work on this product from the very beginning. It also has an inbuilt research mode. You might know those research mode from tools like Perplexity, for example, but Perplexity is often sometimes not approved for company-wide usage, right? Company-wide data, and AWS is there usually already used by multiple departments, already approved for usage within your company, and that is why the Pippin, the quick research mode can also give you and help you research, doing deep research on a technical side, but obviously also on all other things, product management and so on and so forth. Finding product market fit, those kinds of things is what Pippin research mode, quick research mode is really good at. So with that, we've also covered the research and plan phase of the SDLC. Amazon Quick, if you want to go further and want to customize those agents, we also have Amazon Bedrock Agent Core, where you can build your own customized agent and go fully custom. You can integrate those agents into other tools, into Lambdas, into container images, and so on. And that would be something you can have a look at if the out-of-the-box features of Quick are not enough for you. So we've talked about developer personas, we've talked about product manager personas, but we didn't talk about teams yet, right? So we only talked about single personas like PMs using this tool, developers using that tool. How do we get that all of that together into an AI teammate which covers the whole team, so to say? What is this AI teammate supposed to do, right? It's supposed to be a proactive team member, so it's supposed to listen to the team conversation, proactively suggest things which might be the right thing, the right next thing to do. It also needs to help you to automate routine tasks at scale. So for example, if you wanted to upgrade library version or whatever in your code, that is something which would be nice to hand over to an AI teammate. It also should remember past interactions, so it should know that you talked about a specific item 2 weeks back and that your preference on frameworks is React, for example, if we talk technically again. And then obviously the end goal is that it frees developer time, but it also frees other personas time, like product managers. Again, internally, we have a tool called AI Teammate. What it does, as we use Slack quite a bit at Amazon, it connects and brings together everything at Slack level. So basically, you create a Slack channel, you add the product people, you add the people who are working on the project to that Slack channel. You invite the AI Teammate to the channel. Then you can add SharePoint, you can add custom document sources on S3 whatsoever. An AI teammate will have access to those. And then you can actually start chatting with AI teammate and your other teammates because they can see everything which is in the Slack channel. And you can then again ask it, for example, to analyze documents, to create tasks for you, and then use those tasks in order to implement them, which can also be done by AI teammate. If we want to again look at how you as a customer can make use of AWS technology to do similar things, we need to talk about Kiro Web, AWS DevOps Agent, and AWS Security Agent. And let's start with Kiro Web first. So Kiro Web is what I mentioned early on with the IDE, right? So the spec-driven development approach, creating user stories, creating user acceptance criteria, but it's offered via a web interface. So you can chat with it as a developer, but obviously also as a product owner and create your requirements documents via this web interface. In this example, I'm being a technical persona and I ask it to look at my GitHub repository and update it from CDK, which is our infrastructure as code tool, from CDK version 1 to version 2, which has lots of breaking changes. I also asked it to reduce other technical depths like updating Lambda versions or updating dependencies. And it will start working directly on my GitHub repository, right? I fire off this prompt, and then I can close my laptop. I don't have to do anything anymore. It will create a PR. If I'm happy with what it created, I can just merge the PR into my main branch, and then I'm done with it. And this is obviously also something which can help you to get more stuff done in the background while not having to wait for the agent all the time. Next up, Security Agent. So the functionality of Security Agent I like best actually is the one covered here last, so penetration testing. So usually, obviously nowadays we release to production quite often, daily, every hour. I don't know how often you release, but you usually release more often than you do penetration testing, right? So you have penetration testing happening once a year maybe by an external company, and this is where Security Agent can come in and can pen test your web apps, give you some findings, also give you remediation advice. And along with that, when shifting left on security, we also would want to have security reviews early in the phase, so we can already start at design time to tell Security Agent, hey, these are my security requirements, and then I can have Security Agent proofread my designs and then also my PRs against those security requirements. DevOps Agent is something you can use to automatically triage issues happening in production, right? It will start kicking in once you receive an alarm via CloudWatch, via Datadog, via whatever observability tool you use. And then it will start looking at the data sources in order to find the root cause of that issue. So it will correlate issues with latest deployments, with log messages, and so on. And this is why it helps you when in the middle of the night you get a call, something is down, you end up with opening the AWS DevOps Agent and then already have a root cause analysis done and a potential remediation strategy presented to you by DevOps Agent. So that actually concludes the whole SDLC, right? We didn't cover maintain and transform, where we have AWS Transform and AWS Transform Custom. Just not enough time today, but you can obviously also visit us at our booth to talk about AWS Transform. It can help you to move, for example, from VMware to EC2, to move from Windows-based .NET to Linux-based .NET Core, or you can add custom transformations where you can update runtime, move from one framework to the other, move from JBoss to Spring Boot, and so on and so forth. And with that, I'm handing it over to Robert to show you some demos and how to go AI native. Thank you.
Cool. Thanks a lot, Jörg. Change this a little bit up. Cool. So today, I'm wondering why my mic isn't working. Is it? Yeah. Should be. I hope. Okay. I recorded a little demo for you to bring all the things together that Jörg just presented to you. So let's say in this demo, I want to show you the whole SDLC from beginning to end, and we go through the various roles that you have along the way to actually deliver software. In this fictional example, let's say I'm the product manager, I'm the product owner. My boss called me and they said, well, we need a new conferencing app for our reInvent, our big conference at the end of the year. And to do that, we actually want to build something completely new. So can you kick that off? Now, as a product manager, I might now go into Quick and I actually start an internal company research. That's what Jörg showed you before. And in this case, I want to do a research on like, okay, what is actually typical pain points, typical needs of users that go to conferences, and what should a conference app do? So I can give this as a prompt, and as you might have seen, I could have also added like internal company knowledge in here. So that's the big difference where something like Perplexity is only working on public data, but here I could actually pull in internal Wikidata if it's available to Quick, and it could also use that for the research. Now, this takes some time, and then I go back to that screen and I get a full research on basically what's kind of the market analysis on like conferencing apps. And I can read through this, and while I'm doing this, I also see all the references. So I can basically see what kind of data from public sources or internal sources Quick actually used to come to the conclusion of that research. And sometimes there might be things that I'm not agreeing with, so now I can actually collaborate with Quick. So here in this case, it might have some reference or it might draw some conclusion that I actually don't agree with, and I can now actually give it feedback to that. So this is actually a living document. I can actually select parts of it and then comment on it like you would in a Word document, and I would actually give the AI feedback on what I don't like about this or how it should reframe the specific thing it said. And then when I'm done with the commenting, I can basically generate a new version. So the AI will go back to the drawing board, take in my steering, my advice, my wishes, and then come up with a new version of that research. Now the cool thing is, this actually has a multiplayer mode. So I don't have to do this alone. I can actually share that document with my whole team or with all the stakeholders involved, maybe design, maybe security, and they can all make comments, and then we can create a new joint version with all the inputs from the team. So that's just giving you an idea of like how new agentic experiences that are made for collaboration can actually help you to work together as a team and not just having this like one-on-one conversation with an agent. So now basically created a version 2 of that document. You can see the version tag up there at the top. So it basically went back, created a new version with my input, and actually here what I'm seeing is it actually changed that angle where I said, well, I don't agree with that, find a different way to frame this. And then what I can do, I can actually share it. So as I said, Quick has a lot of sharing features, and now what I do is I put this research document into what we call a space. And the space is essentially a container of all the context, all the data, all the documents that you want your agent to work with when you are working on a specific project. So you've seen I put this into a space that's called, New reInvent App 2026. So that's my space where I put all the information I need to create like the product requirements for this new app. Speaking of product requirements, this is where I use like the normal chat feature of QuickSuite, right? It's still a normal agent. And you can build your own agents very simply in the web interface and actually share those with your colleague. So here I've created a product requirements document generator agent. And in your company, this could, exactly take the steps and the guidance that you would use to create product requirements. And then you could share this with all of your product owners inside the company. They can even fork it and create their own, so it can work on multiple levels. And here I basically tell it to create the product requirements documents for this new app that I want to build. And as you might have seen, I actually choose, for additional context, that space where before we put in the research that we created. So now it will obviously take that research into account when it's actually building our product requirements document. I think we will see this in a second, that it will actually draw on that knowledge. And as you go along, at some point, right, you might have your first draft of that product requirements document. That's what we see on the right side. And now I kind of need to hand this off, right? And we saw this before with Amazon. Quick can basically integrate with all kinds of data sources. It natively supports MCP servers, which is like the standard interface to give agents access to data and actions in your company. So I actually have it connected to our Jira here. And so I can basically ask it to hand over the first tickets for the first spike, for the first prototype into Jira that then the developer could pick up to implement. So this is essentially where the product manager work for now is done. And now we're actually switching into the developer view. So this is the Kiro IDE, which is basically a fork of Visual Studio Code. It has a built-in AI assistant for coding. And as Jörg pointed out, it has some really nice accessible feature to do spec-driven development. Because now we want to go from that high-level user story to actual implementation. And I will show you how Kiro is helping us with that. So first of all, let's say it's a new start of the day for me as a developer. I can just chat to Kiro and I can have the same MCP server configured. So now in my role as a developer, I actually pull down all the tasks that have been assigned for me. And of course, surprise, we find the task that the product manager created for me. So we can basically pick that and now ask Kiro to go into spec-driven design to actually implement that. It's even asking me if I want to do that, so it suggests to me that we want to move into a spec-driven development mode, because this is actually a separate, dedicated mode in Kiro. You can chat to it normally, like we are doing here, but then we can also switch into this very structured way of defining specifications, defining the technical design, and then implementing the tasks for the product. So the first thing it does is, and you see it at the very top, it has these 1, 2, 3 steps. So the first one is basically extending the requirements, refining the requirements. So it comes up with a structured documents on all the requirements for the specific app or feature that we want to build. It tries to establish a common language as part of that requirements document. And now I would basically work together with the agent on refining, checking upon this document before I move on to the next phase. Now, in the next phase, we're going to the design step, and that's actually the technical design. So just now we're actually getting technical. Before, we were really focused on business requirements and user stories. Now we're looking into what the technical design is doing. So here we see coming up the design document, and this is basically a mix of, obviously text, but also all the diagrams that you need, architecture diagrams, flow charts, and so on. So now it's trying to basically translate those business requirements into the actual technical implementation. And again, I would work together with Kiro to validate that it understood the design correctly. I can obviously refine that together with the agent, and then actually move on to building out the tasks. Now, if you look at this diagram, that's still, let's say, pretty generic. It took some best practices on what it thinks how the architecture could look like, and now we want to enrich this actually with how our company builds. And for that, in Kiro, there is the concept of powers. So powers are very similar to agent skills, if you know that concept, and it's basically a set of knowledge that you can activate on demand to inform the agent's actions. And here, for example, we're using this to add additional knowledge about how to build stuff on AWS, because we're building the backend for this app on AWS. And we're also using Amplify, which is like the full stack framework of AWS. Now, in your company, you might build your own powers, your own skills, to set whatever guidelines you have for building software. Maybe you're using Kubernetes and so on, so you can do this as well. And now that we loaded this knowledge, and you see that it started using Kiro powers, you see that it basically updated the diagram, because now we loaded this knowledge to inform the agents on how we would typically build this stuff. So this is how you can get your company guidelines into the design during the spec-driven development with Kiro. Now, the final task is basically looking at the task list. And in the task list, Kiro is trying to do context management for you. So you might have heard of context engineering, about the context window of agents, that agents cannot really store all the information in a single session. And a typical problem that arises is that if you want to build something like this, like a whole app, if you try to tell the agent in one session to do it, it might actually be pretty hard for it, because as the context window of the agent fills, it starts to forget things, it doesn't adhere to your guidance anymore, and you might have to correct it a lot. Now, Kiro basically has a built-in mechanism to solve that problem for you. So it creates this task list, and again, obviously, you can refine the task list together with the agent. But then, this is an interactive task list where you can basically click on the single task, and then it will start a new dedicated session just for this task. And it only loads a bunch of steering files that it can also auto-generate to give context about the project that we're working on. So typically, these are things you need to do by hand, right? You need to think about, okay, when do I hand off to the agent? What do I write into a document? When do I start a new session? How full is my context window? But Kiro tries to do this work for you out of the box by destructuring the task into this task list and then running each task in a single separate session for you. So this is basically the idea that Jörg talked about, that all these kind of techniques that you can do by hand, we're seeing them move more and more into the tools itself, so it's already there. And that's not just the case for Kiro, you see similar features in other AI coding tools as well. Now, let's say we've built the code, and now we pushed like our first version of that code to our GitHub repository, and now security agent is coming in. So security agent basically listens to all PRs coming to our GitHub repository, and it will start doing a security check, a security review of our code. And what we see here is that it actually found that there's a very easy way to impersonate users. So obviously, our authentication layer wasn't built very well. Maybe I did this on purpose. And then it will basically tell us exactly where in the code the problem is happening, and it will also figure out where there are additional steps and pieces in the code where the same issue is happening. So it tries to very holistically look at the whole code base and where this security issue might come up. So let's say we fix all of that, and we finally go into production or into a first beta of our app. We actually need to do some DevOps stuff. So I would like to know from you who here would say they are working like somewhere in DevOps, SRE space. Who's that role? Cool. And who here is a developer? Yes, awesome, cool. Yeah, so we're at DevOpsCon, right? So let's talk about DevOps, and let's talk about the DevOps agent. So let's say we have that little software, our conference app in production, but there's actually a problem. We have an alarm raised, so our SRE or DevOps person, or even the developer, depending on how you work, they jump into DevOps agent. And the cool thing about DevOps agent is it has scanned your whole AWS account. It knows all the connections of all the stuff you have deployed, how it works together, and how it's configured. It figures this out on its own, so you don't have to do that. It basically scans your account autonomously in regular intervals. And so it has a view on like how your whole application is built. And if you have an alarm, you can basically automatically trigger a DevOps agent to triage and investigate this alarm. So here we have a CloudWatch alarm being raised because something is wrong with our app. And now you can see in this timeline that basically DevOps agent already started investigating the issue. By default, it has a read-only access to your account, so it can look at the configuration of resources, it can look at metrics, it can look at logs, and it does this very thoroughly with a lot of tool calls and sub-agents to really figure out, okay, what went wrong, and then it comes back with an hypothesis for you on what's actually the root cause for this problem. So you see here, it does things along the way like filing observations, even generating graphs on what it saw. Things you would typically see like in an incident ticket you have internally where humans do that, do the investigation, post the investigation to the ticket, so more and more data is available. And here basically DevOps agent does most of the work for you. And here in this example, it actually figured out that some resource was misconfigured and some capacity was reduced a lot. So that is actually the basically root cause of that issue. Obviously, that's a fictitious issue we put down here, but you can see how thorough it is in investigating what's actually going on. Now, when it comes to conclusion, you can actually click on that button and go to the root cause. And in the root cause, it gives you a quick overview of what actually happened. So this might also be a good summary that you can put then in your internal incident ticket. And then it even comes up with a mitigation plan. So it basically creates ad hoc a little run book for you or for the operator or whoever is basically on call to actually fix the issue that was just encountered. So at this point, you would judge if the hypothesis is right, and then you can work together with the agent to actually run through the mitigation plan. So in this case, because it's a very simple app, it basically generated all the AWS CLI commands we would need to raise up again the capacity of the database to what is actually needed. And it was smart enough to actually measure what it thinks the database needs so that we're not running into the next incident. Now, that's a little bit of a view into how the DevOps agent helps you specifically when you have an incident. But as you can see, it's also a normal chat agent. So you can think a little bit of it like your command center for your AWS account or for your application infrastructure. Because it has access to your whole account and it knows all these connections of the services you configured, you can basically use it for any kind of investigation. So here, for example, I just gave it an ad hoc question about the alarms that we're seeing, and you can see again that it basically uses all of its built-in tools to give you an answer. So you can also ask it things like, hey, check the capacity on my various databases. Can we do like an ad hoc review of our metrics, all these kinds of things. And we see a lot of customers basically use that because it's a very handy tool from an SRE or DevOps perspective to have somebody to basically chat with your infrastructure. So that's a little bit of a view of how AI can work in any part of the SDLC. So I hope this gave you a little bit of an idea. Now I want to talk for a moment about the very, very future, of going completely AI native. And one of the things that Amazon learned here is that you really need to think about your baseline. Amazon has this tagline of eliminate, automate, assist. And what they're meaning with that is if your CI/CD is complicated, if your platform is hard to use, if there's not a lot of self-service, if teams are not autonomous, it's really difficult even to pick up speed with AI agents. So, and this is something we've seen in a lot of industry reports, and also Amazon saw this a lot, that basically you need to fix your baseline, all the things, all the debt you already have. To some extent, you need to resolve that to actually get more juice out of AI and get faster. Because the same things that are going slow today, that are bottlenecks today in the SDLC, they hit with AI agents even harder. And basically what Amazon saw that throughout this whole SDLC lifecycle, whenever you try to optimize one part with AI, another one becomes the bottleneck. So it became kind of like a cat and mouse game, where in the end, what they really figured out is you can only improve up to a certain point, and after that, you have to completely reinvent the process. So actually, the teams at Amazon that gained the most speed with AI were really those teams that asked, why do we do this process even? Why do we have this handoff? Do we still need that? Because if you don't ask those questions, AI will run into the same wall that already the humans went when you try to be fast. And this is like one of the, I would say, key learnings from Amazon, that you cannot just, sprinkle AI on top of it and expect, huge gains in speed, but you actually still need to fix the basics that probably many companies have neglected for a long time. So with that, I want to conclude this session. I think we have a little bit of a time for a few questions. Yes, please. Mm-hmm.
Is it already happening, or do you foresee? So how does that impact your organization?
Mm-hmm. Yeah.
I can imagine that the current technical soil, you have product manager, technical product manager, developer, testing, QA, or whatever. How does that look like in the 6 months, 1 year, 2 years from now?
Mm-hmm. Yeah. So your question is about like how does team composition, team structure change with AI, especially if you go more AI native. So I would say at Amazon we have a little bit of an unfair advantage because Amazon already had this idea of like what they call the two pizza teams, so teams being rather small, and Amazon typically hiring very technical. So it's less, I would say, of a hard transition as for other companies. But the general trend we're seeing, and there's actually a recent talk I can share with you later where we talk about this, is teams getting smaller and teams becoming more generalists. So the idea being that somebody who has a very clear focus on something in business or something in tech, they kind of need to become more of generalists, so they're trying to pick up more knowledge from the other domains that are part of what they're doing. And then the parts where they are weaker, because, me, I might be a developer, but I don't know too much legal stuff. This is where, for example, the legal domain experts over time build up knowledge for agents so that an agent can help me as a developer to also think about legal stuff. So it gets broader, and everybody basically tries to somehow encode their knowledge into agents, into skills, so that other people in the team can use it. But generally, it feels like teams are getting smaller because you want to try to reduce the amount of friction through handoffs while you're building and delivering. Any other? Yeah.
I have a question for the DevOps. Is there, so you presented it and it showed it does a root cause analysis and then presents some steps that it suggests.
Mm-hmm.
And is there some kind of YOLO mode that you have that says, okay, I don't want to get paid at 3 a.m. Can I configure it somehow that I
Yeah, it's a good question. So you asked for YOLO mode. So can you set up the DevOps agent to basically fix the issue, basically give it right access and trust it to do the fix for you? Currently not. My understanding is this is actually something the team is working on. The first version of that might still be with human review. So this mitigation plan that we saw, right now you as a human would run it. Maybe in the future there's a step where you can basically press a big button and say, yes, that looks good, do it, but then it does the rest of that for you autonomously. So the short answer is yes, I think it will move into this direction, that this will be an option for you. Yes?
You get to interact with Mythos, because I know AWS was one of the partners they opened up to part of the glass wing before it got banned.
Yeah, me personally not. Did you, Jörg?
No.
I know of a few lucky colleagues, mostly people from Amazon platform engineering teams who used it, but yeah, unfortunately I couldn't see or touch it.
They're saying it's as impressive as the rumors are?
I haven't, so the question is like, what I can say about Mythos and what I heard like internally, honestly I haven't got any like personal accounts from people yet on what they saw, so fortunately I only have the same information you could find online about people talking about it. All right, I think we don't have any questions.
No, in the chat, no questions.
So if you like this session, please rate us on the app. That helps us a lot also to get better. And one more thing we can offer you. You find us at the AWS booth here in the big room. If you want to try out Kiro, we can actually give you 500 credits for free for Kiro. So you can try out the spec-driven development mode that I showed. So just feel free to come to our booth. We would love to hear your AI story, what worked for you, what failed maybe spectacularly, because both things are true at the same time with AI. So yeah, and maybe you want to pick up some credits for Kiro. Seeing you there.
Thank you.